Good morning, everyone, and a pleasant morning to all the students. Once again, welcome for the chemistry webinar. Dear children, in our last session, you have listened to Mohammed Jahangir Garu, PGT Chemistry from TSMS Bantwaram, Vikarabad district. And today, it's the time for the second lesson in states of matter. In our last session, Sir has explained you regarding the introduction part of gaseous state, isn't it? Then into how many states of matter is divided into how many substances, gases, liquids, and solids. And today, Sir is going to explain you the gas laws and the intermolecular forces. Good morning, Jahangir, sir.
Good morning, madam.
Once again, welcome for the chemistry webinar.
Thank you, madam. Thank you.
Sir, please revise the topics what you have taught in our last session. Why? Because due to some
Okay.
technical difficulties, you have
Okay.
missed a few parts, no? So today, please
Okay. Okay.
continue that and please
Okay.
continue the session, sir. Thank you.
Okay. Okay.
Okay, sir.
Ricky phone.
Good afternoon, respected principals and teachers. Good afternoon, children. So, once again, welcome to this webinar session. So today I am going to continue the lesson states of matter, lesson 2. So in the last session, we discussed about matter. What is the matter and definition of matter? How many types of matters are there? Solid state, liquid state, gaseous states, and interconversion of matters, like conversion of solid state of matter into liquid and liquid to gases. So during the conversion of matters from one physical state to another physical states, the two factors are influences mainly. One is temperature and other one is what? Pressure. So next one is interconversion of matter. So solid to and vice versa, gas to solids, like one physical state of matter is converted into the another physical state. So conversion of solid to liquid is known as water fusion or melting, and vice versa, liquid to solid is called as a freezing. Similarly, liquid to gas is called as a evaporation, and gas to liquid is known as what? Condensation. And conversion of physical states from solid to gas is called as sublimation, and vice versa, gas to solid is known as what? Solidification. So overallly, one physical state of matter can be interchanged into the another physical states, depends upon temperature and pressure. So these are the two important factors which influence the physical states of matter. Okay, so today's session we are going to discuss these topics, like types of molecular forces, intermolecular forces versus thermal energy, gaseous state and their physical properties, gas laws like Boyle's law, Charles' law, Geluzog law, and Avogadro's laws, and some numerical problems based on the gas laws. So these are the topics we will discuss in this session. Okay. So now come to the one is types of molecular forces. Types of molecular forces. Whether the any physical states of matter, either solid state of matter or liquid state of matter, build up of basically molecules. So in between the molecules or within the molecules, the force of attractions are present. Such forces are known as molecular forces. So these forces are categorized into two types. The first one is known as intramolecular forces. Nothing but is called as a bonding. And the second type of forces are called as intermolecular forces, is known as non-bonding forces. So molecular forces, two types: intramolecular forces and intermolecular forces. So the basic definitions of intra and intermolecular forces will quick revise. So intramolecular means, in simply we can define the forces exist within each molecule. The forces are exist within each molecule is known as what? Intramolecular forces. Intramolecular forces. Example, like if you take a oxygen molecule, what is the molecular formula of oxygen, children? What is the molecular formula of oxygen? Yes, O2. O2 is the molecular formula of oxygen. So if you write the structure of oxygen molecule, O is a symbol of oxygen and O is a symbol of oxygen. Another. So in between two oxygen atoms, bonds are present. Like so, two covalent bonds are present. These forces are known as what? Intramolecular forces. These covalent bonds are nothing but intramolecular forces. So that is the intramolecular forces. And the come to the second one. Second one is examples of intramolecular forces are ionic bond and covalent bond. And next second one is intermolecular forces. Second one is what? Intermolecular forces. Intermolecular forces are nothing but force of attractions exist in between the molecules are known as what? Intermolecular forces. Examples of these intermolecular forces are van der Waals forces and ion-dipole forces. So see the children, air, you know the air? Yes, around us air is present. So air is a mixture of oxygen gas, nitrogen gas, carbon monoxide gas, some inert gases are present. Let us take in air mixture of several gases. Air is consist of oxygen molecules like O2. What is the molecular formula of oxygen? Children, what is the molecular formula of oxygen? O2. So here you take one more molecular formula of oxygen, O bond, double bond, O. So this is a oxygen molecule O2 and this one is another oxygen molecule O2. So here the bonds present in between O double bond O double bond O, these are what? Intramolecular forces. They are called as what? Intramolecular forces. So in addition to these intramolecular forces, in between oxygen molecules, the weak forces are present. So I showed you the dots. So the weak forces are present. These weak forces are known as what? Intermolecular forces. Intermolecular forces. So like molecular forces are categorized into two types, intramolecular forces and intermolecular forces. These forces are known as what? Intramolecular forces. Intermolecular forces and these are intramolecular forces. So in the previous lessons, the chemical bonding and molecular structures discussed clearly about the intramolecular forces like a chemical bond formation, covalent bond and ionic bond. All those concepts very clearly explained in the chemical bonding structure. So in this chapter, so in this chapter we are going to next one is so here we'll discuss about continuation of types of intermolecular forces. Types of intermolecular forces. So types of intermolecular forces. There are 5 types of intermolecular forces. So first one is what? Dipole forces, dipole induced forces and dispersion forces, ion dipole interactions and hydrogen bonding. And these first 3 are called as was van der Waals forces. Dipole and dipole induced dipoles and dispersion forces are known as what? Van der Waals forces. And next one is ion dipole interactions and hydrogen bonding. So come to the first type of forces are what? Dipole forces. So see the children, first one is what? Dipole forces. So dipole means what? Di means two, pole means what? Two charges. So positive charge and negative charges. So the molecules which possess dipole, the molecule, another molecule also which possess dipole. In between the dipole and dipole molecules, a force of attractions are exist. That force of attractions are known as what? Dipole forces. So usually dipoles are formed in between the unequally shared pair of electrons. Unequally shared pair of electrons, so dipoles are formed. So partially negative charge and partially positive charges are developed. So due to the partially negative charges of one dipole molecule and partially positive charge of another dipole molecules, in between attractive forces are developed. These forces are known as what? Dipole forces. The best example here clearly shown you with the example of formation of HCl. Okay. So next one is so some points regarding this dipole forces. Dipole forces are the force of attractions which acts between the polar molecules. These dipole forces are operates between what? Nana? Polar molecule, childrens. Polar molecules means you know what is mean by polar molecule. So if electron pairs are unequally shared in between the atoms are known as what? Polar molecules. Electron pairs are unequal shade in between the atoms are known as what? Polar molecules. Such polar molecules such polar molecules are shows this type of dipole interactions. So during the polar molecules are lie near one another partial charges, means one polar molecules are approaches to the another polar molecule. See children, here HCl is a one polar molecule, another HCl is another polar molecule. If these two polar molecules are come close together, if they are approaches to each other, in between these polar molecules attractive forces are develops. That attractive forces are known as what? Dipole forces. So some of the common examples are here. You can see sulfur dioxide, nitrogen dioxide, hydrogen chloride are few examples you can comes under of these dipole forces. Next, usually the interaction energy means attraction energy between this dipole is directly proportional to 1 upon r power 6. So r is nothing but here distance between the two molecules. Okay, friends. So here rotating polar molecules. This formula is applicable for rotating. Rotating means nothing but fluid like a liquids and gases. And similarly, the interaction energy also directly proportional to 1 upon r power 3. This is for stationary polar molecules. Stationary nothing but like a solid molecule, solid state of molecules. So second one is dipole-induced dipole interactions. Dipole-induced dipole interactions. So whenever a dipole molecules, dipole means having a partially positive charge and negative charge within the molecule is known as was dipole. Such dipole molecules are approaches to a non-polar molecules. Non-polar molecules are nothing but electron pairs are equally shared in between the atoms are known as what? Non-polar molecules. So these polar molecules are approaches to the non-polar molecules. These polar molecules get influences or distorted the electron cloud. Means, see the children here, oxygen molecule shape before and after approaching the dipole molecule. Before approaching the dipole molecule, it is a symmetrical in shape, almost like a symmetrical shape. But whenever these dipole molecules are approaches to this non-polar molecules, the electron cloud is becomes what? Distorted, means disturbed. So due to the disturbance of the electron cloud in these polar molecules, there existence of partial positive and negative charges. So in between the positive or negative charge of a dipole molecule and positive charge of another dipole molecule, the force of attractions are developed. This one is known as well dipole induced dipole interactions, means these are formed in between the polar molecules to the non-polar molecules. Polar molecules to non-polar molecules. Here one of the example mentioned clear. H2O is a polar molecule and oxygen is a non-polar molecule. In between what type of forces are present? Dipole induced dipole interactions are present. So the points here, the attractive interaction between the polar molecule and a induced dipole is called as dipole induced dipole interactions. So usually here the nonpolar molecules have larger size that will become what? A less polarizability. What is mean by polarizability? Polarizability is nothing but whenever a dipole molecules are approaches to their nonpolar molecules, the symmetrical distribution of electron cloud becomes distorted, means disturbed. The disturbance of the electron clouds, the disturbance of the electron clouds or symmetrical distribution becomes distorted in a nonpolar molecules by the influence of polar molecule is known as what? Polarizability. So usually if the size of the atom is more, size of the atom is more, polarizability is becomes what? Also more. If the size of the atom is less, polarizability also less. Okay. So next one is third one is what? Dispersion forces are London forces. Dispersion forces are also called as a third type of intermolecular forces are dispersion forces or London forces. So usually these dispersion forces are existed in between the two non-polar molecules or symmetrical distribution of electrons are same in between the two atoms. In such type of atoms or in between the non-polar molecules, these dispersion forces or London forces are exist. So see the first point, children. So these type of forces, which type? Dispersion forces or London forces exist in atoms and non-polar molecules are electrically symmetrical and have no dipole. And have no dipole. Type of molecules are in between the atoms. These type of forces are exist. Which type of forces? Dispersion forces or London forces are exist. Okay. So but in this type of molecules also, at any one particular moment, the electron cloud get becomes what? Distorted. Electron cloud get becomes what? Distorted. So there exists a partial positive charge and partial negative charge in the atoms. Okay. So like a partial negative charge and partial positive charges also develops in between these electrically symmetrical distribution of atoms. So these type of forces are known as what? Dispersion forces are also called as London forces. On the honor of scientist London, these forces are named as what? London forces. Okay, children. So the next is ion dipole interactions. Ion dipole interactions. So in the name itself only given ion dipole interaction. This kind of force of attractions are exist in between the ion to the dipole molecules. So usually when ionic compounds are dissolved in water, this type of interactions are takes place. Which type of interactions? Ion and dipole interactions are usually occurs in ionic compounds when they are dissolved in water. Okay. So the strength of ion and dipole interaction is depends upon the charge and the size of the ion. So the attraction forces between the ion and the dipole is depends upon what? Students, charge as well as size of the ion. Here you can see the picture once again clearly. So when sodium chloride is dissolved in water, it dissociates as a Na plus and Cl minus. So here Na plus is a ion. Na plus is what, student? Ion. So surrounding of this Na plus ions, these are what? Water molecules. Red ball is shows what? Oxygen atom. These white balls are shows like hydrogen atoms, H2O, 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 water molecules. So water molecules are surrounded by this Na plus ion or positive ions. So in between positive charge of ion to the negative charge of the dipole, the attractive forces or interactions are develops. These kind of interactions are known as ion dipole interactions. Okay, so this is also one type of interaction, children, in between types of intermolecular forces. And the last and final one in this types of intermolecular bonding is nothing but a weak electrostatic force action between the partially positively charged hydrogen atom such as fluorine, nitrogen and oxygen. So here clearly mentioned the bond is formed some high electronegativity elements like fluorine, nitrogen and oxygen. HX hydrogen, and X means any element here, either maybe fluorine or nitrogen or oxygen. So in between the one HX means either hydrogen fluoride or ammonia molecule or other water molecules. Okay. So HX, in between these, dots are represented. These dots are nothing but the symbol of hydrogen. So in a simply way, we can say that hydrogen bond is nothing but the weak electrostatic force of attraction between partially positively charged hydrogen atom to the high electronegativity elements like fluorine, nitrogen, and oxygen. Okay. So this bond is known as what? Hydrogen bond. Okay. So this hydrogen bond is also comes under of a dipole-dipole interactions. But the difference between the dipole-dipole interactions to the hydrogen bond is hydrogen formed by only few elements like fluorine, nitrogen, and oxygen only. Okay. So that is about the special type of interaction. It is a special named as what? Hydrogen bond, and it is little bit stronger than that of dipole-dipole interactions. Children, so these are the 5 types of intermolecular forces are present in between the molecules. Once again, what are the 5 types of molecular forces are present? First one is dipole-dipole forces, dipole-induced dipoles. Third one is hydrogen bonding, and fourth one is dipole interaction, and fifth one is dispersion forces or London forces. Like these are the total 5 types of intermolecular forces, children. Okay. So after this, next one is what is the relation between the intermolecular forces and thermal interactions? What is the relation between intermolecular forces and thermal interactions? What is meant by intermolecular forces? Just now discussed, children. The force of attraction between the molecules are known as what? Intermolecular forces. Okay. Thermal energy is nothing but heat energy or temperature. So what is the relation between the intermolecular forces to the temperature? Okay. So usually the matter is existed in a 3 states like solid state and liquid state and gaseous state under normal conditions. Okay. So any existence of the present state of matter is depends upon the balanced forces or balancing between the intermolecular forces and heat energy or thermal energy. Okay. So example, like if a present existence of a liquid state of matter, water is present. If water is exist in a liquid state because of in that intermolecular forces and the thermal interactions are balanced. If we changed, means either intermolecular forces or the thermal interactions, nothing but heat energy. If we change or the temperature is changed, it changes from one physical state to another physical state. One physical state to another physical states. See children, here predominance of intermolecular interactions. Predominance of intermolecular interactions. As we know, the one of the properties of gas is nothing but in gases the molecules are far away from each other, means intermolecular distances are more. Intermolecular distances are more, means intermolecular interactions or attractions are less, means was temperature is more or thermal interactions are very high. And come to the solids. In solids, if you take in solids, the intermolecular force of attractions are very strong. Intermolecular force of attractions are very strong, and the thermal interactions are very, very less. Okay. And come to in liquids, these intermolecular forces and thermal interactions are intermediate between the gases and solids. Gases and solids. So if we move from left to right, intermolecular force of attractions are increases and the thermal interactions or thermal energies are decreases. Means in gases, intermolecular interactions are very less or weak. In solids, intermolecular attractions are less. Okay. So gases converted into liquids and liquid is converted into solids. So if we move from gaseous state to solid state, intermolecular interactions are increases or predominance, and the thermal interactions are becomes decreases. Okay. And next one is a predominance of thermal energy. As a predominance of thermal energy means as the temperature is increases, usually the temperature is increases, you can observe the solid state of matter is converted into the liquid state, and liquid state of matter is converted into the gaseous states. Means it shows that gaseous state of molecules or gaseous molecules have high thermal energies, and the solid state of matter has. So this is a relation between the intermolecular forces versus thermal interactions. Okay, children. So this is the relation between the intermolecular forces and thermal interaction. So the key point in this is the presence existence of any state of matter. You take solid state of matter or liquid state of matter or gas state of matter, any state of matter, it is present in that particular state in present, it is depends upon purely intermolecular forces and thermal interaction energy balanced. If any one is changed, means intermolecular force of attraction decreases or intermolecular force of attraction increases, definitely it changes from one physical state to another physical state. Similarly in the case of thermal energy also. So like these are the variation between the intermolecular force of interaction to the thermal energy. Okay, students. So next one is gaseous state. So here in the first year level, you are going to discuss about the two states of matter only, children. So one is gaseous state and other one is liquid state, and come to the solid state we will discuss in the second year level, that is. So commonly, what are the characteristics properties of gases? You learned in the lower section also. So you know that gases are highly compressible. Gases are nana? Gases are, students, highly compressible. Compressible means what? We can convert them into large volume into a small volume. Large volume of matter is converted into a small volume is nothing but compressibility. So gases are basically highly compressible, mostly compressible comparatively solids and liquids. And next, the second points under characteristics of properties of gases. Gases are exerts pressures equal in all directions. They exerts of what? Pressures in all directions. And gases have much lower density than solids and liquids because of intermolecular distances are very far or very large. That's why the molecular force of attractions are very weak and their densities are very less. Okay. The volume and the shape of the gases are not fixed. The volume and the shape of the gases are not fixed. This assume that usually the gases are takes place the shapes of the container. And next, last point under the characteristics of gases are mixed evenly and completely in all proportions without any mechanical aid. Means gases are moves or mixed randomly in all directions without any intervention or without any external agency of gases or without any external agency. So these are few basic characteristics properties of gases. Now children, we are going to study the most important topic in this lesson is gas laws. These are the very important, students, for your examination point of view or in a higher level also. This topic is very important. That is what? Gas laws. So gases are possess or gases are follows certain laws. Simply those laws are called as what? Gas laws. Also we can define gas laws are nothing but which gives the relation between the measurable properties of gases, which gives the relation between the measurable properties of gases. So we can measure the properties of some gases. Those properties of gases can be measured. Such gases nothing but those gas laws are some of the measurable properties of the gases are here, children. Mass is one of the measurable, volume, temperature, and pressure. These are the four measurable properties are the gases. So under the gas laws, we are going to study about the relation between these measurable properties of the gases. Means if one variable is kept constant, how does the other two variables are changes? Like if temperature is constant, how the pressure and volume becomes various. If the pressure is constant, how the volume and temperatures are changes. Like if by keeping one variable or one of the measurable properties kept constant And how does this varies from one measurable properties to the other measurable properties of the gas? Okay. So first gas law, some of the gas laws are here given to you children. See the slide. First one is Boyle's law. Second one is Charles law. And third one is Gay-Lussac law. And fourth one is Avogadro's law. So these are the four important. So now we are going to discuss one by one these gas laws. Okay. So first one is Boyle's law. So Boyle's law states that, or Boyle's law gives you relation between the pressure and volume. How does pressure and volumes are interrelated? Interrelated. This gives by Boyle's law. So the statement you can see here, at constant temperature, by keeping temperature is constant, the pressure of a fixed amount of gas is inversely with its value. Means pressure is inversely proportional to 1 by V. Means as the pressure is increases, volume is decreases, or pressure is decreases, volume is increases. This relation is known as what? Inversely proportionality. So like the Boyle's law mathematical form, you can write P is inversely proportional to 1 upon V. Okay. So by removing this proportionality, you usually get a constant. So like P is equal to K into 1 by V. So by removing the proportionality, we get a constant is equal to K into V. By transposition of V, PV becomes what? Constant. So if you take for two different gases, P1 V1 is equal to P2 V2 is equal to P3 V3 is equal to, becomes what? A constant. So that is the basic statement of Boyle's law. Students, what is the Boyle's law statement? Once again, listen. Boyle's law statement is at constant temperature, means temperature should be constant. So at constant temperature, the pressure of a fixed amount of gas varies inversely with its volume. So that is the basic fundamental statement of Boyle's law. P is inversely proportional to 1 by V. Okay. So P is inversely proportional to 1 by V. Okay. So next one is see here diagram. So this diagram shows you relation between the pressure to the volume. So here the gas is filled in a cylinder which is closed with a piston. These are the gas molecules. Dots, the balls are shown the gas molecules. These gas molecules are closed in a cylinder which is a piston. So if you observe these two pictures, yeah, if you observe these two pictures, what do you observe here, children, in these two pictures? Here, volume is increases, pressure is decreases. Here, piston is moving upward. Piston is moving upward means pressure is decreasing and volume is what? Increases. And here in the second picture, volume is decreases, pressure is increases. Here the piston is moving downward and volume is decreases, means as the pressure is increases, volume is decreases. In the first picture, volume increases, pressure decreases. In the second picture, volume decreases, pressure increases. Means what is the relation is there in between the pressure and volume? Pressure and volumes are one each other inversely proportional. Means pressure increases, volume decreases. Volume increases, pressure decreases. So like one increases, one variable is increases, parallelly other variable is what? Decreases. So this is a Boyle's law statement. At constant pressure, the given volume of a gas is inversely proportional to its volume. Okay. So this is about Boyle's law statement and its diagram. With this diagram, I think you clearly understood the statement of Boyle's law, children. Yes. So very clearly here explained here, very clearly here given picture. With the help of picture, you can clearly understand the Boyle's law. Okay. So now come to the graphs, children. So here graphs are plotted between the pressure versus volume. So if you take the pressure is taken on y-axis and volume is taken on x-axis, if your graph is plotted between the pressure and volume, so the graph is plotted between the pressure and volume. A rectangular hyperbola is formed. A curve is obtained. This is what a curve is obtained. Rectangular hyperbola curve is obtained. So this curve is known as what? Isotherms. What do you call, children? Isotherms. This curve is named as what? Isotherms. Isotherms. Isotherms, children. So what are isotherms? Isotherms are nothing but a graph is plotted between the pressure and volume. The graph is plotted between the pressure and volume at constant temperature. At constant temperature is known as what? Isotherms. Iso means what? Same. Therms means what? Temperature. Temperature is a constant. Similarly, you can take a volume on y-axis and pressure is also x-axis. Even in such case also, you can get a curve, rectangular hyperbola. This curve is also named as what? Isotherms. So with these graphs, you can clearly understood what if the pressure is decreases. Here, what happening here? Pressure is decreasing. If the pressure is decreasing, volume is increases. See here, pressure is more. So if the pressure is increasing, here parallelously observe, pressure is decreasing. If the pressure is decreasing, volume is increasing. Volume is what here? Increasing. So like pressure is increases, volume is decreases, or volume is decreases in opposite direction. Volume is decreases, come to left side. Pressure is what? Increasing. So like pressure and volumes are inversely one each other at constant temperature, and these curves are known as isotherms. Called isotherms. Okay. And you can take also the graph between the pressure versus 1 by V. Pressure versus 1 by V. What is the Boyle's law statement, children? What is the Boyle's law statement, children? Boyle's law statement is P is inversely proportional to P is inversely proportional to 1 by V. P is inversely proportional to P is equal to K into 1 by V. K into 1 by V. So if you compare the mathematical equation, it is in the form of a like y is equal to mx. Y is equal to mx. A equation of line y is equal to mx. mx. So here on x-axis, you can take it as a 1 by v. 1 by v is taken on x-axis and pressure is taken on y-axis. Usually the equation of line y is equal to mx is comes from origin only. It comes or passes through the water origin. So y is equal to mx, always a equation of line which passes through the origin. Y is equal to mx here. That's why here graph is obtained from the origin, P versus 1 by V. Similarly, you can take inversely also 1 by V on y-axis and P is taken on x-axis. Pressure is taken on x-axis, 1 by volume is taken on y-axis also. In such case also, you can get the graph a straight line which is passes through the origin. And next one is what? Another graph of PV versus P. PV versus P means PV, product of pressure and volume to the pressure. So if you observe the product of pressure and volume to the pressure, a straight line or a horizontal line which is parallel to what? X-axis is formed. Why this PV is always a horizontal line which is formed x-axis? Because according to the Boyle's law, if one variable is increases, the other variable is parallelly or automatically decreases. If the pressure is increases, volume is becomes what? Decreases. Pressure is increases, volume is becomes what? Decreases. So that's why the overall product PV always becomes what? Constant. Product always what? Constant. So that's why the graph is comes like a parallel x-axis. Parallel to the x-axis. Okay. So this is about graphs of under Boyle's law, children. See here, one more graph of pressure versus volume at constant temperature. These curves already we discussed. It is called as what? Isotherms. What we call as isotherms. So here at different temperatures, different curves are obtained. Why? Because as the temperature is increases, pressure and volume is also parallelly increases. That's why we got a graphs like a 600 kelvins, 400 kelvins, and 200 kelvins. At different temperatures, different curves are obtained. So these are the curves. Curves are obtained at a different temperature. This is a 600 Kelvin, 400 Kelvins, 200 Kelvins. And here one more graph is between the pressure versus 1 by V. See here why we got here different curves at a different temperatures means you can compare with, if you take any one. Example, if you plot a graph which is parallel to x-axis means we are keeping pressure is constant. Pressure is constant. So here at constant pressure we are observing here at constant pressure. So laterally it comes actually PV is equal to nRT. It is called as what? Ideal gas equation is equal to nRT. Called it as a ideal gas equation. Here pressure is constant. Pressure is constant. And anyway, number of moles also constant. R is also constant. What is the relation between V and T? V is directly proportional to student temperature. Means volume is increases, temperature is also increases. That's why here volume is more for 600 kelvins. The temperature is also more. That's why the graph is in the upper layer. Next one is 400 kelvin. Next one is at 200 kelvins. That is the reason for the 600 kelvins. Why we got 600 kelvin gas above and why we got a 200 kelvins graph at below. Okay. So that is the reason, because here V is directly proportional to T. So this is also called as next comes in a gas laws, that is called as a Charles law. Okay. So that is the reason for the different curves are obtained at a different temperature. Okay. Next one is even here second graph also same students. Pressure versus 1 by V. Pressure versus 1 by V at different temperatures. At different temperatures. Here also, if you take a pressure is constant. If you take pressure is constant. So at constant pressure, if you observe these three different graphs, here one line, second line, third line. So here T3 is greater than T2, T2 is greater than T1 is given. Means if we move from on x, what is taken on x-axis 1 by V. So 1 by V, if we move from left to right to left, here V is maximum. Here V is what? Minimum. So V is maximum and V is minimum. Here V volume is maximum. Why? Because 1 by V is less. V is maximum here. Maximum. Because here on graph 1 by V is taken. 1 by V is more means V is less. V is more means 1 by V is less. That's why here less means more V. Volume is maximum. So that's why V is directly proportional to T. That's why T3 is greater than T2. T2 is greater than T1. Okay. Next one is these are the graphs which are observed under the Boyle's law. Okay, children. Next to come to numerical problems here. Go to the numerical problems based on Boyle's law. Very simple, easiest problems First problem is a sample of gas occupies 10 liters under a pressure of 1 atmosphere. What will be its volume if the pressure is increased to 2 atmosphere? See children, here a sample of gas is occupies how many liters? 10 liters under a pressure of what? 1 atmosphere. So here V1 is the initial volume. What is the initial volume? 10 liters. 10 liters of V1. And what is its pressure? 1 atmosphere. Now what we are doing, if the pressure is increased to 2 atmosphere, increase it to 2 atmosphere means 1 atmosphere pressure is increased to what? 2 atmosphere pressure. Then what is the final value? Means V2 is what? So now applying of Boyle's law, according to the Boyle's law, P1 V1 is equal to P2 V2. P1 V1 is equal to P2 V2. So P1 is what children here? P1 is initial pressure. What is the initial pressure of sample of gas? 1 atmosphere. This is given in the data or in the problem. And what is about P2? P2 is equal to 2 atmosphere. Means we are increased from 1 atmosphere to 2 atmosphere. And next, what is the initial volume given? 10 liters. Okay. Now, what about the final volume? Okay. Now, substitute these values in the Boyle's law formula. P1 V1 is equal P2 V2. Okay. So, if you substitute in this formula from this, we can subject as a V2. V2 is equal to P1 V1 by P2. That is equal to P1 1 atmosphere into V1. P1 how much children? Yes, 10 liters. Next P2. What is the P2 children? 2 atmospheres. So by simplifying of these values, 2 ones are 2 5, so 5 liters. What is the final volume? 5 liters. So with this answer, you can clearly understand the Boyle's law children, because pressure is taken initially 1 atmosphere. No, yes. So pressure is taken 1 atmosphere and it is changes to 2 atmosphere. Means here what happened? Pressure is increased, means 1 atmosphere to 2 atmosphere. If the pressure is increased, automatically according to the Boyle's law, volume should be decreases. Volume should be what? Decreases. What is the initial volume? 10 liters. What we got the final volume? 5 liters. Means 10 liter of volume is decreases to 5 liters of volume. Means volume is decreased. Means if the pressure is increased, volume is decreased. Shows the Boyle's law. Boyle's law statement is clearly explained in terms of a mathematical formula or numerical problem. Pressure is increased, volume is what happened here? Decreased. Okay. So that is the first problem. Next, come to the second problem. Minimum pressure required to compress 500 cubic decimeter of air at 1 bar to cubic decimeter at 330 degrees Celsius. So what are the informations are given in this problem? Pressure is given. Initial pressure P1 is equal to 1 bar and P2 is, we have to find. What is the V1 given children? V1 is given 500 cubic decimeter and V2 is 200 cubic decimeter. So applying of Boyle's law, P1 V P2 V2. Okay. So P1 V1 is equal P2 V2. So P1 is equal to 1 bar pressure. 1 into V1. What is the initial value? V1 is 500 is equal to P2 final pressure we have to find. So into what is our final value? 200. So by simplifying, you get P2 is equal 2.5 bar. So this is also clearly showing with this answer. Pressure 1 bar. What is the volume of this gas? V1 is equal to 500. Means at 1 bar pressure, the volume is 500. If 200 cubic decimeter volume is, means here volume is 500 to decrease it to 200. Here the 500 cubic decimeter volume is decreased 500 to 200. If the volume is decreased, definitely pressure should be increased. Pressure should be increased. That's why 1 bar pressure is changes to 2.5 bar. Means here pressure is clearly increased. So this problem also clearly showing that pressure is increases, volume is decreases. Pressure is increases, volume is decreases, or volume is decreases, pressure also increases. So that's why here in this problem, volume is decreased. That's why we got answer is 2.5 bar. Means pressure is increased from 1 bar to 2.5 bar. Okay. So bar is a units of a pressure. Okay. So 1 bar to 2.5 bar. So these are the numerical problems, children, based on Boyle's law. Okay. So then next come to the another one more problem also here. A sample of oxygen has a volume of 800 ml at a pressure of 740 tar. Tar is also units of pressure. What additional pressure is required to reduce the volume of 540 ml? So from this given problem, the information is here. V1 is 800 ml, V2 is 540 ml, P1 is 740 tars, and P2 is we have to find. Same apply the Boyle's law. P1 V1 is equal to P2 V2 and make it as subject. P2 is equal P1 V1 divided by V2. So what is the P1 value? 740 tars, units of pressure, tar also. Okay. So 740 into V1 initial volume 800 ml divided by upon 540. So from this 1096.3 tars are obtained. So this is what a final pressure. Final pressure. But actually the question is what? How much additional pressure is required or applied? Means 740 to 1096 to changes of pressure from 740 to 1096 tars. How much extra pressure you applied? Means subtract from final pressure to initial pressure. So 1096.3 to 740, that gives you 756.3. This is the pressure you are applied extra pressure you are applied here, 356.3. Okay, children. So I hope you understand this about Boyle's law. Next one is what? Madam, shall we continue? Next one is Charles law. Charles law gives you relation between the temperature and volume. It gives you relationship between the temperature and volume. Okay. What is the statement of Charles law? Students, listen carefully. At constant pressure, the volume of a fixed mass of gas is directly proportional to its absolute temperature. Means here the pressure is keeping constant. In Boyle's law, what is constant? Temperature is constant. In Boyle's law, temperature is constant. In the Charles law, the pressure is constant. If the pressure is keeping constant, how does one variable is differed from the other variables? Means what is the relation between the volumes to the temperature? Means it is directly proportional. Means if volume is increases, temperature also increases. Volume is decreases, temperature is also decreases. That means directly proportional. Here T means what? Absolute temperature. So absolute temperature is nothing but Lord Kelvin is introduced a new type of scale to measure from very low temperatures to very high temperature. That is called as a absolute scale. So the temperature is measured on absolute scale is called as what? Absolute temperature. So V is equal to K into T, or V by T is equal to constant. Okay. So if two gases are there, for example, if V1 is the volume of certain mass of a gas and its temperature is T1, and V2 is the value of the same mass of gas at same mass of gas at T2, but constant. According to the Charles law, V1 by T1 is equal to V2 by T2. V1 by T1 is equal to V2 by T2. So this is another mathematical formula of a Charles law is a V1 by T1 is equal to V2 by T2. So what is the Charles law statement, children? Once again, at constant pressure, the volume of a fixed mass of a gas is directly proportional to its absolute temperature. Means volume is directly proportional to temperature. Okay. So here the diagram is clearly showing you how this volume and temperatures are interrelated. See here, children, in the diagram, what is the pressure? 1 atmospheric pressure is, so the gas is closed in a cylinder at 1 atmospheric pressure. Okay. So here the temperature is low. Here the temperature is low because of here no heating symbol is present here, means temperature is low temperature. So as the temperature is increased, the volume of the gas also what increases. The volume of the gas is also increases. So this relation between the volume and temperature. So this is what a new scale which was introduced by the Lord Kelvin to measure the temperatures from very low temperatures to very high temperatures. So this scale is called what a absolute scale. So the temperature measured on absolute scale is called as absolute temperature. So in this absolute scale, the lowest value is known as what? Minus 273 degrees is called as a absolute zero. Absolute zero. So absolute zero means absolute zero is nothing but the temperature at which gas is becomes what? Zero. The volume of the gas is becomes what? Zero is what? Absolute zero means before that reaching the temperature, the gases are converted either in the liquid state or in the solid state. Okay, so this is the relation of Charles law. Okay, so the next graph, children, here the graphs between the volume versus temperature graphs. So in Boyle's law, the graph is plotted between the pressure versus temperature versus volume. Pressure versus volume. Those graphs are known as what? Isotherms in Boyle's law. Come to in Charles' law, the graph is plotted between the volume versus temperature. So if the graph is plotted between the volume versus temperature is known as what? Isobar. Bar means iso means what? Same. Bar is what here? Units of pressure. Isobar means at constant pressure. If a graph is plotted or drawn between the volume versus temperature, the lines, whatever the lines are obtained, those lines are named as, or those lines are called as isobar. Okay, so they are called as what? Isobar. So here the different lines are obtained at different pressures. Here different pressures. So P1, P2, P3, P4 means here the temperatures are changes at different pressures are changes at different pressures. Different lines are up. So this also can be explained with the help of by taking a constant. See here on x-axis temperature is taken, on y-axis volume is taken. So if you take temperature is constant, a vertical line is drawn on x-axis means you are keeping temperature is constant. So temperature is constant. The horizontal lines like you will get 4 lines at a P1, P2, P3 and P4. Okay. So which one has a more volume? P1. P1 has a more volume. Next one is P2. Next one is P3. Next one is P4. So P1 has a more volume. P4 has a lowest volume. So if a volume is more, pressure becomes what? Less, according to the Boyle's law. What is the statement of Boyle's law? Pressure is inversely proportional to, according to Boyle's law, what is the statement, children? Pressure is inversely proportional to 1 by V. 1 upon V means pressure is more, volume is less, or volume is more, pressure is less. So here volume is more for which gas? For P at what pressure? P1 pressure. So more volume means what? Less pressure. So P1 line has more volume means its pressure is low. That's why P1 is less than P2. P2 is less than P3. P3 is less than P4. P3 is less than P4. Also you can write inversely also. P4 is greater than P3. P3 is greater than P2. P2 is greater than P1. Okay. The reason for the graphs why we obtained a P1 at a upper level and P4 is a lower level, or P1 is up or P4 is a down. Why can't P4 is above and why can't P4 is down? Okay. So this is the reason for the graph for we drawn at P1 is above and P4 is below. Okay, children, understood? I think this one. So this here volume is more. Once again, I'm telling you here V is maximum volume because on y-axis volume is taken. Volume is maximum means pressure is what? A minimum. Pressure is what? A minimum. P is minimum because according to Boyle's law, volume is more, pressure is less. That's why P1 is less because V is more. Next P2, next P3, next P4. Okay, so this is the graph about Charles law graph. So what is the name of this graph, children? The name of the graph is called as what? Isobar. What do we call? Isobar. The isobars are once again the graph plotted between the volume versus temperature at constant pressure is known as what? Isobar. Isobar. Iso means what? Same, bar means is units of pressure. Same pressure or at constant pressure. The graphs are formed. Those are known as what? Isobar. Okay. So the next one is numerical problems. So once again based on this Charles law. So what is the Charles law statement? Volume of a given mass of gas is directly proportional to absolute temperature. So for come to the problem, what is the problem here? The volume of a certain mass of gas at 17 degrees Celsius is 400 ml. What temperature is must attain in order to double the volume or reduce the volume to 1/2? So here question 1, but 2 questions are internally there. The question is double the volume and the second question is reduce the volume to 1/2. So come to the first question here. First question solution A, V1. V1 means what? Initial volume. What is the initial volume? 400 ml. In the given problem, it is given 400 ml. And V2 is how much? 800 ml. 800 ml. Why? Because in question it is given double the volume. Double the volume. 400. If you double the 400, what is its value? 800 definitely. Okay. So 400 is if you doubled, it becomes what? 800. So V2 is 800 ml. And what is the temperature T1? 17 degrees Celsius. If you convert the degrees Celsius into the Kelvins, add 273. So then it is converted into the 290 Kelvins. So why? Because the Charles law is calculated in terms of what? Absolute scale only. That's why the temperature should be in what? Kelvins. Okay. So now question is what is the temperature? Okay. Applying of Charles law, V1 by T1 is equal to V2 by T2. So from this T2 is equal to V2 into T1 divided by V1. Now substitute those values in this formula and you will get 580 kelvins. That is nothing but is equal to 307 degrees Celsius. Why? Because the relation between the kelvins and degrees Celsius is the relation between the Kelvin and degree Celsius is Kelvin scale is equal to, or Kelvin is equal to K. K means what? Kelvin scale K. So K is equal to 273 plus degree Celsius. See here children, see. So this is what C. So K is equal to, so K is equal to 273. K is equal to what? 200. So K is equal to Kelvin scale. K is equal to 273 plus degree Celsius. So you can use of this formula. You can convert from kelvins to degrees and degrees to kelvins. Means 580 kelvins are nothing but equal to 307 degrees Celsius. Now come to the second problem. So what is the second problem, children? Here, if double the volume over, next one is reduce the volume to 1/2. So here volume is what? Reducing. In the previous problem, volume is what? Increased. Volume is what? Increased. Volume is increased. Temperature is also increased. We got answer. See children, 290 kelvins, 580 kelvins. T1 is initial temperature 290 kelvins, final temperature T2 is 580 kelvins. Here volume is doubled, means it changes from 400 to 800, and temperature also changes from 290 to 580. Means here clearly Charles' law is obeyed or not? Yes, V is directly proportional to T. Value means 400 to 800. Volume is increased from 400 to 800. Temperature is also increased from 290 kelvins to 580 kelvins. 290 kelvins to 580 kelvins. See here, 400 ml to 800 ml. 400 ml to 800 ml means volume is increases, and temperature is also increased from 290 kelvins to 580 kelvins. 290 kelvins to 580 kelvins. We got a increased temperature only, na? Right. Okay. So now the second problem is, now we are going to reduce the volume. Means 400 ml is initial volume. We are reducing to 1/2, means off, exactly off. 400, if you reduce the off means how much? 200 ml. So 400 to 200 ml, that is equal to T1 is equal to 290 Kelvin. That is a T2 is equal to question mark, means we have to find out. So same applying of Charles law, T2 is equal to V2 into T1 divided by V1. So that is equal to 200 into 290 divided by 400. That is equal to 145. Means volume is decreased, means 400 to 200. Volume is decreased. Here 400. Volume 1/2 means 200. Means volume changes from 400 to 200. Now temperature is what? T1 290. And what is the T2 we got? 145 kelvins. What is we got? We got 145 kelvins. Means if volume is reduced, means 400 to 200 ml, temperature is also reduced, 290 to 145. Means it is clearly shows the volume is directly proportional to what? Temperature. Volume is directly proportional to temperature. Clear?
Please revise,
So
sir.
this is a numerical problems. Yes, okay, madam. Yes. So this is the numerical problems based on the Boyle's law and Charles' law. Okay. Now come to the once we do what we have learned. So children, what we have learned today? So today we learned the review of the session. We have learned today types of molecular forces, intermolecular forces, thermal energy, intermolecular forces versus the gaseous state and the gas laws, Boyle's law, Charles' law, and numerical problems based on Boyle's law and Charles' law. Today we discussed in this session. Okay, children. So now I'm going to give some simple question to you. So once you solve these questions, yeah. So let us try this. So these are the simple and easy questions given to you. Just you go through this. Letting correct relation according to the Boyle's law. Which of the following correct relation according to the Boyle's law? First one, P is directly proportional to V. B, V is directly proportional, inversely proportional to 1 by P. C, V is directly proportional to T. And D is P is directly proportional to T. So which one is correct, children? So try at home. Okay. One is the second question. the graph between the volume and temperature. If your graph is plotted between the volume and temperature at constant pressure is known as A. Isotherms, B. Isobar, C. Isocore, and D. Isomers. Children, today we discussed different types of graphs, Boyle's law, Charles' law, and their names also we discussed. So once you read and answer these questions, and last two more questions. Now, third question, which of the following element do not form hydrogen bond? Which of the following element do not form hydrogen bond? A. Oxygen, B. Nitrogen, C. Sulfur, and D. Fluorine. So today we discussed the hydrogen bond also. So once you revise that hydrogen bond topic and after the revision, you solve these questions. Okay. And last and final question, maximum intermolecular force of attractions are present in intermolecular force of attractions are present in A. Solids, B. Liquids, C. Gas, D. Both B and C. Both B and C. Okay, children. So intermolecular forces also we discussed it today. So in which case solids are more, liquids or gases, or which one has more intermolecular force of attractions? So revise today topics. So whatever I have explained you clearly, those topics once you go through, and after that you solve these questions. Okay, children. Okay. Okay, madam.
Thank you, Jahangir sir. Indeed, it was a very excellent session today.
Thank you.
We don't have any
Thank you, madam.
Technical issues, and you have very clearly explained about the gaseous state and all. Dear children, so in the last part of this session, sir has given you few multiple choice questions, isn't it? See, in that he has given you, so which type of atoms doesn't show the hydrogen bond? Just think over about the hydrogen bond, because you have already learnt about hydrogen bonding in the chemical bonding, isn't it? So please revise all those topics, right? So starting from the atomic structure, please revise periodic classification of elements, chemical bonding, and today's lesson, it is the states of matter. And sir has very clearly explained you regarding the problems also. Please do the numericals and write down the notes. And thank you, Jahangir sir, for your wonderful presentation.
Thank you, madam.
Thank you. We thank everyone for giving us this great opportunity.
Thank you, madam.
Thank you, sir.
Okay, thank you.